So RAG is not one thing. People talk about RAG as if it was single technology, but it is not. It is a family of technologies. Usually online there are a lot of tweets and blog posts saying RAG is dead, RAG is broken, this new technology just broke RAG, or just use a long context window and forget about it. Embeddings will solve every problem. And most of the time, people are describing different technologies, different problems, and they're assuming that they are all talking about the same thing. So let me divide you the RAG, the ecosystem of RAG into different pieces that actually behave differently, and there are different approaches to that. So there are two dimensions that matter. The first is about the knowledge. The second is about the product that you are building. And as will turn out, the second dimension will be more important than the first. So the first division is static RAG versus dynamic RAG. In static RAG, we have the simplest, most dependable form of RAG. You have one body of technology, a handbook, a policy, a manual, product specifications. You paste the whole thing into the prompt as context every turn. That's all. No index, no similarity search, no graphs, no infrastructure. People call this like a toy. It's too easy. And it's getting less of a toy every 6 months because the context window keeps growing. Today, a single file can be a 200-page manual easily, and the models are better at retrieving the needle in the haystack. So retrieving is going to be better and better. So static RAG is an option. Static RAG has two strong properties. First, it's bounded. It knows one topic and knows all of it. No retrieval step can miss the relevant passage because every passage is already there in every turn. Second is dependable. The model is grounded in the whole source. We don't need to guess about which slice of the content is relevant for this query. For one handbook, one syllabus, one set of regulations, pasting the whole thing is the correct engineering answer. But there is a catch. The whole file writes in the prompt every single turn, sitting there and moving, and we are paying a lot of tokens just to retrieve one page of 200. So this is expensive.
Before we watch, fix the shape of the software you are building, because everything in this lesson sits inside it. A retrieval application is 3 layers. At the top, a chat interface. It holds the conversation you can see, your turns, and the assistant's replies, and nothing more. At the bottom, the language model. Between them is the layer that does the work, the assistant endpoint. The endpoint is stateless. It keeps no memory of its own. On every call, it takes the bare conversation from the interface, looks up how this assistant is configured, retrieves the material, and assembles the full prompt for the model. The system instruction, then the history, then your question with the retrieved text beside it. One design choice makes this powerful. The endpoint speaks the same interface as the model behind it, the OpenAI Chat Completions Application Programming Interface, the API. From the outside, it looks like any other model endpoint. That buys compatibility. Any standard client can talk to your assistant, and you can change the model underneath without touching anything in front of it. Hold the stateless part. Because the endpoint remembers nothing, the retrieved material is rebuilt on every call and then discarded. Watch that happen now.
Do a demo of the Context Explorer. If you see, I am here in the terminal, and I am in our repo in the week 2 demos Context Explorer wrap. I created by doing UV vent, then I activated it by source activate it. I activate it like this, and then I did the UV sync. So the packages are there, and then let me show you the files in the directory. I have this README file which you can read, and I have a knowledge.txt, which is the text that I'm going to do as the RAG source, as a single file RAG source, and this is my script. And I have this .m file that I created using the env example, that I'm going to cut it for you. And you can see that I'm using the model Ministral, which I'm running locally in my machine, and the OpenAI endpoint that is here in the local host machine under Ollama. So what I have to do right now is just launch the program, UV run Context Explorer. So let me go down, and this is the application. I'm running the Ministral model. This is localhost. It's run in the localhost as the endpoint, so it's a local machine running, and I have some information about here. So this is my system prompt, answering only the context provided. If the system is not in the contents, say that you don't know, just instruction, the file is in genetic pattern, and the prompt template is, this is the context, this is the questions, and will be used every turn. And this is the knowledge file, which is a file about a fictional company called Acme Robotics, which has a flagship product that is funded by somebody, and we can ask questions about it. So I'm going to ask a question. Where are you based? So the answer was really fast, so let me see. This is what the chat UI sends to the endpoint. There's just one message from the user, where are you based? Nothing else. Now the system is going to augment this by doing things. So what we have our system prompt, and we're going to build the query with the template on the user end. So what we actually send to the LLM is this JSON content, where we said this is the model and these are the messages, the system prompt, and now the user sends actually all the contents of the file, all the contents on the file, and the question is, where are you based? Here. The temperature, this is the message, and this is the response. Acme Robotics is based in Girona, Catalonia. So I have the response of the assistant. Acme Robotics is based in Girona. Okay, but the chat UI history, what the user sees and the chat application is going to store, what is going to be persistent is these conversations. The user asks, where are you based? And Acme Robotics is based in Girona, in the naive RAG implementation. If I say, okay, and what is your flag? What is your flagship product? Now, again, we have that what the UI sends is again the first question, the first answer, and the second question. And now the system, the endpoint, is going to build the call, and now we have what we send to the LLM is again the array of messages with the system prompt, with the first question, just the bare question, not the augmentation that we did, then the actual answer that we got, and now the next question is augmented again with the file. Okay, so what we see is that we are, for each time that we do the query, we are sending over and over and over the file.
You saw the gap. What the chat interface stores is only the bare turns, your question and the answer. The system instruction and the retrieved file never enter the conversation the user sees. The endpoint built them for that one call and discarded them. So the model does not remember the document. It remembers the conversation. Each new turn retrieves the file and sends it again. The whole file, every turn. You watched the prompt token count climb while the questions themselves stayed short. For one bounded document, this is still a real engineering answer. But it leaves two limits, and the rest of the week is about both. The first is size. One file fits. 1,000 files or a single 500-page manual will not. And then you cannot paste everything. You have to retrieve only the part a question needs. That is where we go next. The second is the one the reading left hanging. The file does not change between turns, and yet we pay to send it on every turn. There is a smarter placement for a file that never changes, but what it saves and why only makes sense once we learn to read the bill. We come back to it with the numbers in Lecture 2.4. The demonstration gave you a split vision: what the chat interface sees, the bare turns, and what the system actually processed, the system prompt and the retrieved file, built for one call and discarded. You might want to keep that second half. And you could. You could build a single, monolithic application that remembers every message actually sent to the model, not just the turns the user saw, and on top of it, design sophisticated multi-turn augmentation schemes. And yet, almost no one builds this. There are two reasons. The first is the standard. The moment your assistant becomes a stateful, bespoke thing, it stops being a drop-in, OpenAI-compatible endpoint. You give up the contract the whole ecosystem already speaks, and you customize your entire codebase instead. The standard is worth more than the cleverness. The second is that there is a better tool. That sophisticated multi-turn case, deciding what to retrieve, when, and how to carry it forward, is exactly what an agent does, and far less clunkily. So when you reach that level, you do not weld it into the assistant. You reach for an agent. That is the second dimension we set aside at the start, the product, and it is where this course goes next.